Hi, I'm Melissa.
Hi, my name is Uliana, and we will be covering multiple state models. So up until this point in class, we have been using the alive-dead model, where an individual life-aged X moves from the alive state to the dead state. And we have defined Tx to be the time until death of the individual aged X. But in reality, we have a continuous process. So we define a new variable y of t, which is equal to 0 if X is alive at t, and 1 if X is dead at t. Therefore, we now redefine the random variable tx to be equal to the maximum of t and y of t is equal to 0. So in general, there are many policies which can be modeled by more than one state.
One example of a policy is where the insured is covered by more than one death. For example, the person with the insurance policy can have an accidental death, or they could have another death, such as natural causes. In these two states, they would likely be paid out a different benefit.
In another model, we have the permanent disability or critical illness state. So what this means is that an individual can move from the alive state to the permanently disabled or ill state, and then move on to the dead state. Once an individual moves to the disabled state, they can no longer move back into the alive or healthy state. An individual can die from both the alive state and the permanently disabled or ill state. The force of mortality between the alive dead and the disabled dead state will most likely be different. A lump sum is typically paid upon an individual's movement to the disabled state and further on the dead state.
A similar example is where the individual is healthy and then sick. But in this example, the individual can go back to the healthy state after being in the sick state. Generally, this is an annuity contract where the individual is paid a disability annuity while they are in the sick state.
Yet another kind of contract is called the joint life contract, where benefits are paid out contingent on the survival or death of two policy holders. These are typically given out to couples. So we have 4 different states depending on if both X and Y are alive, either X or Y are alive, and when both X and Y are dead. Typically, the model will go through the process of either one individual dying and then further on to where both of them are dead. However, we do have a common shock force where both X and Y can die at the exact same time. This, for an example, in a car accident or other tragic event.
A final example is often covered through an employee's retirement benefits. So they start off actively employed for the company, and depending on the company's policies, they can retire, they can die, they can withdraw from the contract, or they may be under disability and retire. This we often refer to as the multiple decrement model, as each transition from the employed state into the other states is a single force.
When we start looking at multiple state models, there are several assumptions that we need to make that we did not have in the typical alive-dead model. First off, the time until transitions must be differentiable. Secondly, the Markov process must hold, which means that the future movements of YT depend only on the present state and not on the history before the present. So this means that no matter how long an individual was in the healthy state, if they are now in the sick state, that is all that matters in determining the force at which they will transition into a different state. And lastly, the probability of having 2 or more transitions in a very small amount of time is negligible or close to 0. So that means as we make h, the time frame, smaller and smaller, it is less and less likely that an individual could transition between to make two separate transitions.